Now, in this entire process, what happens? Since the decision making rule says, that t equals to beta hat divided by standard error of beta hat, that should be greater than the tabulated t. So, that means your decision making rule involves some kind of probability distribution. So, decision making, this implies reject your null. This is the decision. Since the decision making involves probability distribution, of beta hat, what will happen? We will make mistakes in the process, because that is the nature of probability. If all 100 cases your decisions are correct, when you are following this rule that tabulated t is less than the calculated t, if all 100 decisions are correct, then that cannot be a probability kind of situation. Since the decision making rule involves some kind of probability distribution, we would definitely commit some mistakes or error in the decision making process. Okay? These mistakes or error. These errors in hypothesis testing are two types. So, type 1 error and secondly type 2 error. Okay. Now, I will explain this type 1 error and type 2 error. What is the definition of that? Let us say that this is a situation H naught, this is say that reject H naught, this is do not reject H naught, do not reject H naught. Here H naught is true, H naught is not true. Okay. So, here I am just writing here H naught is not true, H naught is true. So, think about this case, H naught is not true and you are rejecting this, or I will write like this. First case is, let us say H naught is true and this is H naught is false. Okay. So, think about this case, your null hypothesis H naught is true and you are rejecting the null. you are rejecting the null. That means you are committing mistake. H0, the null hypothesis is actually true. So, you are rejecting a true hypothesis. So, that means you are committing a mistake. So, rejecting the null when it is true is called type 1 error. Type 1 error. What about this? H0 is true and you are not rejecting also. That is a correct decision then. Correct decision. Correct decision. H0 is false, is not true, and you are rejecting the null hypothesis. That is also a correct decision. That is also correct decision. Think about this case. H0 is false and you are not rejecting also. This is called type 2 error. So, that means how do you remember type 1 and type 2 error? Type 1 error is rejecting the null when it is true, and type 2 error is do not reject your null when it is not true. This is how you have to remember. Rejecting the null, that means now I can define that type 1 error, type 1 error is rejecting H0 when it is true, and type 2 error not rejecting the null when it is not true. Okay, this is the simplest way to remember type 1 and type 2 error. Rejecting the null when it is true is type 1, not rejecting the null when it is not true is the type 2 error. Now, here in the hypothesis testing, as we said, our decision making rule involves some kind of error. We need to minimize these errors. Now, the question is, can we minimize these errors, both the errors simultaneously? Can we minimize? So, our objective in hypothesis testing is to minimize these errors. Then the next question is, can we minimize both the errors simultaneously? Can we minimize both the errors simultaneously? Now, if you think about the nature of these two errors, you can see that type 2 error is just opposite of type 1 error. Type 1 error says rejecting the null when it is true, and not rejecting the null when it is not true is just the opposite of that. That means, if I denote type 1 error is, let us say, by x, type 2 error is just denoted by, let us say, minus x. So, obviously, you cannot minimize x and minus x simultaneously, because minimizing x indicates maximizing minus x. Okay? So, that is why since type 2 error is just the opposite is just the opposite of type 1, we cannot minimize both of them simultaneously. Okay? We cannot minimize both of them simultaneously. Then what is the idea? If you cannot minimize both the errors simultaneously, what the statistician they suggest that you identify the most severe one. You identify out of these two errors which is the most severe, type 1 or type 2. So, which error is the most severe one? Now, I will give you a small story to understand which error is the most severe one. Let us say that a person is caught by the police. A person is caught by the police and the police suspect the person is related to some bank robbery, but there is no enough evidence of that. So, you suspect him and now the court in the court you have to produce the person, the guilty person in the court, and then there would be trial in the court and the judge will decide whether he is actually guilty or not. So, the person is caught. So, what is your claim? Your claim is that the person is guilty. When the person is caught, so what is your claim? Your claim is the person is guilty. The person is guilty. Then what is your H naught? Your H naught is that the person, so you have to nullify this claim, the person is not guilty. Not guilty. Then what would be your type 1 error in this context? Type 1 error. So, you reject the null when it is true. So, that means you are rejecting the null hypothesis, the person is not guilty, you are rejecting this. So, what will happen? The person is actually not guilty, but you are rejecting it when it is true. So, you are sending this person behind the bar. Okay? So, that means type 1 error is sending an innocent, sending a person behind the bar when the person is not guilty. So, you are sending an innocent person behind the bar when you are committing type 1 error. Then what is type 2? What is type 2 error? Type 2 error says not rejecting the null when it is not true. So, that means the person is not guilty, that is not true. That means the person is actually guilty, but you are not rejecting the null. Okay? The person is not guilty, is not true. That means the person is actually guilty, but you are not rejecting it. So, you are accepting the fact that the person is not guilty, but actually the person is guilty. Rejecting the null when it is not true, the person is not guilty is not true. So, that means the person is innocent is not true. What is true then? The person is guilty, but you are not rejecting it. That means the person is not guilty, you are accepting that. So, what is type 1 error then? Allowing a guilty person to go free. Now, if you think about these two cases, obviously when you are sending an innocent person behind the bar is most dangerous compared to the second one, because the justice says that you can even let a person go free when he or she is guilty, but you should never send an innocent person behind the bar. Why this is so? Because in the first case, you are not only sending an innocent person behind the bar, you are allowing the actual guilty also to go free. This person is caught out of the suspect, but the person who is actually guilty is moving around. So, that means we can say the type 1 error is actually twice severe than the type 2 error. So, type 1 we can say that type 1 is twice, 2 times more severe than type 2, because here you are allowing a guilty person to go free, nothing is happening to the innocent person. Here the innocent person is going into jail and the guilty person is moving around. That is why we say that type 1 error is most serious. Then statisticians say that since the type 1 error is most severe, you keep the type 1 error fixed at a pre-specified level. That means in the process of hypothesis testing, we cannot allow type 1 error to be fixed out of the process. Rather, since this process is so, type 1 error is so severe, what we will do in 100 cases when you are taking the decision based on the decision making rules specified earlier, we will say that we can afford of making type 1 error maximum 10. So, 10 times, that is the number we can afford. Maximum 10 times we can commit type 1 error. That means, and probability of committing type 1 error, probability of committing type 1 error is called level of significance. Probability of committing type 1 error. When you are rejecting the null, what is the minimum number of type 1 error that you are committing? That is called your level of significance. That means in terms of the diagram, when I am saying that this is 5%, that means this is alpha by 2 equals to 0.05 by 2, and this is 0.05 by 2. So, when alpha equals to 0.05, what we are saying, the probability of committing type 1 error is called level of significance. That means the size of the critical region is also known as level of significance. That means I am saying when I am rejecting the null based on the rule we have just specified, that calculated t should be greater than t, tabulated t, we will commit minimum 5 times type 1 error, that is the meaning. And then you minimize, keeping type 1 error at a pre-specified level, and then minimizing the type 2 error is the actual procedure. So, in the process we will allow maximum 10 type 1 errors to be committed. Lower is better, lower is better. So, that means from the diagram we can say that this alpha is 5%, that means alpha equals to 0.5 and 0.5 means I have specified probability of committing type 1 error 5%, that is a priori specified. Fixing alpha equals to 0.05, now we are trying to minimize that probability of type 2 error. You can fix probability of committing type 1 error at 1% level also, okay, 1% level also. So, that means what is happening in terms of the diagram, once again, let us say that this is our, so this is alpha by 2, this is also alpha by 2. So, while these two are called critical region, so critical region how the critical region and level of significance is related, we say that size of the critical region, size of the critical region, I will write here, size of the critical region is called, size of the critical region is called level of significance. So, that means when your size of the critical region is 10%, you will commit 10 type 1 error while rejecting the null, and we will say that the variable, let us say in our context income, is significant at 10% level. When I am saying income is significant at 10% level, that means I am saying that while rejecting my null I am committing 10 type 1 error. When I am saying the variable is significant at 5% level, that means I am committing type 1 error 5 times. When I am saying the variable is significant at 1% level, that means I am committing only one type 1 error while rejecting my null hypothesis. Okay. So, these two areas is alpha by 2 and this is 1 minus alpha, 1 minus alpha. So, from this, from the area property of this distribution, from the area property of T distribution, or we can say that a T which will lie between minus T alpha by 2 and T alpha by 2, sorry, this is minus T alpha by 2 and T alpha by 2, the probability is actually equals to 1 minus alpha. Okay, 1 minus alpha. And what is T? T here is beta hat minus beta divided by standard error of beta hat. Now, substituting T here, what I can write, that probability minus T alpha by 2 less than equals to beta hat minus beta divided by standard error of beta hat less than equals to T alpha by 2 equals to 1 minus alpha. Or from there what we can write, after some rearrangement we can write that beta hat minus T alpha by 2 into standard error of beta hat less than equals to beta hat into beta hat plus T alpha by 2 into standard error of beta hat equals to 1 minus alpha. Now, we have constructed one probability statement following the area property of the T distribution. Now, the question is, what is the meaning of this probability distribution? So, that means when alpha equals to 5%, you can say that this area is actually 95%. Okay? Since these two regions are called critical region of rejection, we say that 1 minus alpha is called region of non-rejection, a region of non-rejection. So, what is the meaning of this? You have constructed, that means some interval. When you estimate your beta hat, let us say that this is an interval and this is an interval. Let us say that this is the lower limit of the interval and this is the upper limit of the interval. How the interval is defined? Beta hat minus T alpha by 2 into standard error of beta hat is called the lower limit of your interval. Beta hat plus T alpha by 2 into standard error of beta hat is called upper limit of the interval, and this is 95. So, what does this probability statement says? Apparently, it may so appear, you may like to interpret this probability statement as this interval will capture the true value of beta, the population parameter beta. Probability that this interval will capture beta is 95%. Probability that this interval will capture beta is 95%. That may appear as an interpretation, ready-made interpretation. Since this is a probability statement, there are two intervals here. So, I will say that probability that this interval will capture the true population parameter beta is 95%. Okay? But you have to sincerely keep in mind that interpretation is wrong. Why this is wrong? Because probability can always be attached only with a random variable. First of all, is this interval a random variable? Is this interval random? The answer is no. Why? Look at the interval, it is beta hat minus T alpha by 2 into standard error of beta hat. Once you estimate the model, you know your beta hat, you know T alpha by 2, you know standard error of beta hat. That means this lower limit is known, upper limit is also known. That means the interval itself is known. So, when the interval is known, it will either capture beta or do not capture beta. Where is the probability here? We cannot attach a probability with an interval which is known to us, right? Then the question is, when the interval is known to us, we cannot attach probability. Then what is the meaning of this probability statement? The actual meaning of this probability statement is that if you construct this type of interval 100 times following the formula beta hat. So, what is the formula we are following? Beta hat plus minus T alpha by 2 into standard error of beta hat. This is the formula I am following, and following this formula I am constructing 100 such interval from 100 different samples, because 100 different samples will give you 100 such beta hat, and standard error of beta hat I will get from the probability distribution. Then if you construct the interval, out of 100 intervals, 95 of such interval will capture the true value of beta. What I am saying? If you construct the interval following this formula, 95 of such intervals will capture the hypothesized value of beta, in this case which is actually 0. Okay, 95 of such intervals will capture the true population parameter beta. Since the true population parameter value is unknown, we will say that 95 of such intervals will capture the hypothesized value of the true population parameter. Now, in this process we have defined the interval estimation also. If you recall, we say that there are two type of estimates: interval estimate of beta hat, or of beta. So, instead of saying the beta hat as a point estimate, here I am now giving an alternative estimate of the beta, which is called interval estimate. And how is the interval estimate defined? Beta hat plus or minus T alpha by 2 into standard error of beta hat. So, higher the value of the standard error, higher would be the size of the interval. Okay? The interval would be size of the interval, and lower would be the preciseness. If your interval, size of interval is much wider, then obviously that will lead to very lower level of precision. Okay? Lower the value of the standard error, you will give more preciseness in your decision making. So, this is an alternative to point estimate, which is more reliable, because I can always represent a value of the true population parameter by an interval rather than just by only one point given by the point estimate of beta hat. Okay? This is how we can construct the interval estimates. So, how will you check the level of significance then? Once you estimate the model, you get your interval, and if your interval captures the true value of the population parameter, obviously you do not reject your null. So, do not reject your null when your interval captures the hypothesized value, and reject your null when your interval does not capture the true value of the null. Okay? So, the rule in interval estimation says if interval, what is the rule? If interval captures the hypothesized value of beta which is equals to 0, then reject H no, sorry, do not reject, then do not reject H naught. And if interval does not capture the hypothesized value of beta, then reject H naught. This is the decision making rule in the context of interval estimation. So, this is actually the entire process of hypothesis testing. So, hypothesis is basically a guess about the true population parameter, and we have two types of hypothesis, null versus alternative. Null says when you are nullifying your claim, alternative is just the opposite of that, and then you get a test statistic based on your estimates beta hat divided by standard error, and your decision making rule is says that when your estimated calculated value of the t is greater than the tabulated value of t, you reject your null. And since the probability distribution is attached with this decision making, we commit some kind of mistakes or errors in this decision making. There are two types of error, type 1 and type 2. Type 1 error is most severe, as I discussed giving the example. We fix a priori the probability of type 1 error like this, that we are fixing actually the size of the critical region. When I am saying I am fixing the number of type 1 error, I am actually fixing the size of the critical region, and then we are trying to determine what is my area of non-rejection, 1 minus alpha, right. And then once you specify, and then you try to see what is your calculated value of t at that whether your calculated value of t is greater than the tabulated value of t at that pre-specified level of significance. That means, size of the critical region is also known as level of significance, and it is also known as probability of committing type 1 error. So, probability of committing type 1 error, size of the critical region and level of significance, these three terms are interrelated. Size of the critical region, probability of committing type 1 error and level of significance. So, when I am my variable is significant at 5% level, that means I am saying I am rejecting the null, but I am committing 5 mistakes, that is okay. I can afford of committing 5 mistakes. I can afford up to 10, but econometrician they say that it is better to fix your type 1 error at 1% and 5%. If you commit more than that, while minimizing type 2 error, it may so happen that you are committing type 2 error more than 5 times or more than 10 times, then we will say that my variable is actually not significant. We cannot afford of committing that many type 1 errors, okay, that many type 1 errors. This is actually in the process we are getting an alternative estimates of beta, which is called interval estimate. How we are getting? From the area property of the t distribution, and the interval is defined as beta hat plus or minus t alpha by 2 standard error of beta hat. This is how we are going to get the interval. So, with this we are closing our discussion on hypothesis testing. So, tomorrow we will bring back our original model, what we are discussing, what we are estimating, and we will see how to apply this concept of hypothesis testing there to check whether a particular variable is significant following the level of significance approach or following the interval estimate approach. That we will discuss in our next class. Thank you.